Good afternoon. This is the last session of the first day of the LivenArch VIII Congress. And today we are going to listen to 4 presentations within the panel, 4 important research papers. And we will be focusing on the politics, policies, laws, regulations, ethics, and design concepts of the Congress theme. All right. So we finished the first one, and the second presentation will be is titled as Regeneration of Urban Space via Degeneration of Urban Planning: The Case of Post-Earthquake Urban Policies in Turkey by Yasemin ILKAY.
Yes, thank you.
And Yasemin joins us from Van, right?
Yeah.
And thank you, and welcome on.
I will explain. Yeah, okay.
It's yours. Thank you.
Hello, I'm Yasemin ILKAY. Today, I'm from Van University and I'm a city planner. Today, I'm going to present a paper on regeneration of urban space via degeneration of urban planning, the case of post-earthquake urban policies in Turkey. First of all, there are 3 turning points, critical turning points of earthquake policies, and the latest one we experienced on 6th of February, and 2 consecutive destructive earthquakes took place, unfortunately, in Kahramanmaras, and more than 50,000 people died during this disaster, and the disaster impacted a whole region of about 10 cities. The previous turning point was 1999, especially the 17th August Gölcük earthquake, and this was the peak of turning points. In fact, with respect to earthquake policies, several legal and institutional transformations have been made after these earthquakes. But the very, very first turning point was 1939 Erzincan earthquake. Almost 33,000 people died, and this was assumed as the most destructive disaster of 20th century in Anatolia. Turkey experienced several huge earthquakes with a magnitude more than 6.5 and more than 7. And 1939 Erzincan earthquake happened in the era of urbanization of state. And during this era, state was the main actor shaping the urban space and controlling the planning paradigm. And 1999 earthquakes took place in the era of urbanization of capital. This was labeled by Şengül. And within this period, neoliberal policies dominated the planning and urbanization, and a shift from use value to exchange value was experienced. And especially after 2002, with the elections, a new era started with the ruling party GDP. And after this, ruling party shaped both the urban space and planning paradigm. And after 2010, we experienced the dominance of the president. So the first quarter of 21st century is the era of GDP, urbanization. The research question of this paper was, we saw the events of disasters. So how does the central state in Turkey reflected such a deep and compelling experience onto urban policy planning to create more resilient cities? So to answer this question, I investigated main characteristics of three most destructive earthquakes through four basic categories. These were domain and the feature of the disaster, basic post-disaster policy and action plan, role of planning, and role of the concept of resilience within the regeneration of the urban space, and through investigating institutional and legal deregulations within this period. First turning point was, and the first huge earthquake was 1939 Erzincan earthquake, and this earthquake impacted the city and ruler of Erzincan and resulted in a change of the location of the city with a parliament decision, with a law. So the policy concentrated on curing and healing policy with a fatalist point of view. Within an incremental planning, we couldn't see the concept of resilience. But after, within the process, within the period between 39 Erzincan earthquake and 99 Gölcük earthquake, some developments was witnessed, and 99 Gölcük and Düzce earthquakes threatened the most developed city and the region of the country. So both the pre-disaster mitigation and post-disaster healing interventions shaped the policy, the management disaster management policy, and the concept of resilience also entered within this policy package. However, implementations were not so successful because they were concentrated on short-term, quick interventions, and new settlement decisions and urban transformations were usually made by statutory degrees, partial statutory degrees, not by a holistic law until 2012. Within this date, a new law on urban transformation numbered 6,306 was legislated. And lastly, after 2012 Maraş earthquakes, we observed rapid decisions as new development areas via presidential decrees, and special decisions have been centralized by the GDP government, so planning was excluded. The press statements of professional chamber of city planners tried to create a discussion and public opinion on this degeneration, but unfortunately they couldn't be successful, and the process is still going on, and we will see if planning will be used as a tool to create more resilient cities or not. These are my references. You can see them on my paper. Thank you for your attention.
Right, another very informative presentation by Yasemin İlkay. Thank you, Yasemin. Probably if we had the Congress face to face in Trabzon, we would now applauding the presenter, and like we always forget when we make it online. So yeah, applauses from now to all presenters, as we remember just now. And yeah. And again, the table that shows the comparison of different earthquakes that happened in Turkey is very insightful. Thank you for presenting that such an academic, robust information for us. And probably the attendees will be thinking and making some questions to the end of the session. Thank you. All right, dear guests, our third presentation will be by İdil ERDEMIR KOCAGIL, and the title of her presentation is Design of Energy Efficient Housing Settlements in Kahramanmaras after the earthquake.
Yes, thank you for the presentation.
Thank you.
Hello, my name is Idil and I will present the study titled Design of Energy Efficient Housing Settlement in Kahramanmaras After Earthquake. I begin my presentation with an introduction, followed by outlining the objectives, discussing the methodology, presenting the results, and finally concluding the presentation. As we all witnessed in February 2023, a series of devastating earthquakes struck southeastern Turkey, resulting in extensive destruction and tragic losses. Post-earthquake assessments revealed that around 13% of the building stock were demolished or damaged. In response to this crisis, the government promptly launched reconstruction efforts. The Housing Development Administration, as known as TOKİ, announced ambitious plans to construct almost 250,000 housing units. While rapidly constructing earthquake-resistant housing is commendable, rebuilding cities requires more than just construction. It demands a comprehensive urban plan, considering cultural heritage, history, social structure, topography, and climate. Sustainable environments require time, expertise, and inclusive planning based on collective studies. In the 21st century, urban development must emphasize sustainability to mitigate the negative effects of unplanned urbanization on people and environment. These earthquakes not only damage our cities, but also pose environmental threats with millions of tons of waste. Therefore, post-earthquake reconstruction urges us to focus on sustainable design solutions, like more energy-efficient settlements to protect our environment. So settlement design not only shapes urban areas, but also influences building energy performance. Urban geometry, characterized by height-to-width ratio, and urban form, which outlines how neighboring structures relate, plays a crucial role in determining solar access level and, in turn, passive building performance. Therefore, to enhance energy efficiency, we must optimize solar access potential while carefully considering design parameters and environmental data during the initial design stage. In this context, the study aims to investigate how urban geometry can enhance building energy performance in Kahramanmaras. Therefore, we have constructed a parametric study with 4 steps. The first step is definition of design parameters. This initial phase involves specifying parameters that encompasses climate, user, urban and building forms, as well as active building subsystems. In generation of settlement scenarios, various scenarios were generated based on the defined design parameters. In the last stage, the performance of these scenarios were assessed, considering energy consumption and solar radiation gain. Let's begin with the definition of design parameters. Climate and user-related design parameters were established as provided in the slide. For the study, a hypothetical plot was designated in Kahramanmaras, where the scenarios were situated. The reference building typology was formulated following an analysis of TOKİ's project. The reference building was composed of a residential module with a floor area of 100 square meters. 2 plan layouts were generated, a square plan with 4 modules and a rectangular plan with 2 modules. The reference building was designed with a height of 15 meters, featuring 5 stories. To analyze the effect of different urban forms on building energy performance, we used 2 basic layouts, pavilion and slab. These urban forms were devised based on pavilions with a square plan layout and slabs with a rectangular plan layout to ensure that each module could receive solar radiation from 2 directions. To comprehensively analyze the influence of urban geometry, 16 different height-to-width ratios values within the range of 0.5 to 2 were employed with intervals of 0.1. Layering details of the opaque and transparent components of the reference building were created in accordance with the limit values for Kahramanmaras specified in thermal insulation requirements for buildings. Regarding the active systems, the provided values and details were incorporated into the model. After the design parameters defined, 32 settlement scenarios were generated from various combinations of height-to-width ratio and urban form parameters. The reference building for energy performance assessments was placed at the center of a 5x5 grid within each scenario. For energy performance assessment, the annual results per module of the reference building were calculated. Performance data were generated using the Design Builder simulation program, including heating, cooling, lighting, total energy consumption with solar radiation gain. The results obtained for the reference building in each settlement scenario were presented in this graph. As you can see, variations in solar radiation gains significantly affected passive heating, cooling, and daylighting potential in buildings, consequently leading to differences in energy consumption among scenarios. The settlement scenarios with higher height-to-width ratios had limited solar access capabilities because the closer proximity of adjacent buildings resulted in overshadowing. The results of the urban typology evaluation exhibit a similar trend between solar gain and energy consumption results. The reference building in the pavilion configuration consistently received higher solar radiation gain due to its detached configuration, which allows for solar access from all directions compared to the slabs. As we know, design solutions achieving an optimal balance between heating, cooling, and lighting energy consumption resulted in more energy efficient built environments. To define the overall impact of design parameters, the total energy consumption performances should be analyzed. According to these results, differences up to 20% based on height to weight ratios and up to 25% based on urban form were identified in energy consumption. It was evident that higher radiation gain is more beneficial for Kahramanmaras considering energy efficient design. This study aimed to investigate the influence of urban geometry on building energy performance instead of pursuing a single ideal solution in urban design. So regression analyses were conducted in order to reveal the impact of each variable. It is clear that height to weight ratio indicates a substantial influence on solar radiation gain with a high R-squared value of 0.9. Among energy consumption results, the most significant impact was observed in heating energy consumption with an R-squared value of 0.4. Cooling and lighting energy showed less sensitivity. In the regression analysis conducted for urban form, similar results were observed. The impact of urban form was not as effective on solar radiation gain with an R-squared value of 0.6 as height to weight ratio parameters. But it was seen that the alteration in urban form had more significant impact on heating energy consumption with a higher R-squared value of 0.8. Comparing different settlement scenarios revealed that higher solar radiation gains were linked to improved energy performance due to a significant reduction in heating energy consumption in Kahramanmaras. However, these results were obtained within the framework of the study from the various assumptions and limitations of the methodology developed. For settlement to be built, appropriate design alternatives should be investigated that establish the optimal trade-off between heating, cooling, and lighting energy consumption. In conclusion, design solutions increasing solar radiation gains in future residential settlements of Kahramanmaras may significantly improve energy efficiency. However, exploring various design options to balance energy consumption is always required. Rebuilding Kahramanmaras post-earthquake goes beyond urban development. It's about reviving the city's identity. This requires a comprehensive urban planning and respects cultural heritage, history, social structure, topography, and climate. Creating sustainable urban spaces demands inclusive planning rooted in detailed studies. Given the energy crisis and the urgency of addressing global warming, embracing sustainable design for energy efficient cities is imperative. With meticulous planning, it is feasible to transform Kahramanmaras into a more sustainable urban area, recognizing the profound influence of urban geometries on building energy efficiency. So thank you for listening.
Thank you for the presentation, Idil. It was very nice to see the results of all these 32 scenarios, design scenarios, and it's a kind of lying parallel to the previous presentations. The session is kind of like a package of information sets, and I'm happy to see different approaches to the disasters and their consequences. So in the first presentation, we've seen examples of quick installations of spaces, architectural modules, right, in disaster areas. It's kind of addressing the need, the initial need of space for the residents, and the second one was considering the policies that lie behind all these issues that come in front when the earthquake happens. And the third one is now considering post-disaster. Again, we are moving to the post-disaster area, but this one is more like the larger impact of doing architecture in this kind of places. So very happy to see all these packages of information together presented within one session. that completes all the missing part, I think. And last but not least, we have one more presentation now, right? And its title is Examination of the Concept of Suspended Ceiling and Earthquake in the Architectural Departments in Turkey in terms of curriculum content. So we are jumping to the education now in the same stream, and the presentation will be by Sila YILDIRIM.
Thank you for the presentation.
Thank you. Yeah.
Hello, I am Sila YILDIRIM. I will present to you our study titled Examination of the Concept of Suspended Ceiling and Earthquake in the Architectural Departments in Turkey in terms of curriculum content. First, I would like to talk about the scope and importance of our work and problems we focused on. Not all buildings that survive an earthquake can be defined as earthquake-resistant buildings. During an earthquake, the safety of the non-structural elements in the building is as important as the safety of the structural elements and load-bearing system. For this reason, non-structural elements must also maintain their integrity under the influence of the earthquakes, because damage to non-structural elements during an earthquake significantly affects the functionality of the building and causes the use of the building to be restricted. And in some cases, possible, this situation becomes very important for certain types of buildings, hospital, transportation buildings, etc. That should primarily maintain their functionality after the earthquake. In addition to functionality, failure to maintain the integrity of non-structural elements during an earthquake can become a safety hazard and lead to injuries and deaths. After an earthquake, it may cause loss of life by restarting rescue force. In past earthquakes, the seismic behavior and poor performance of non-structural components have become safety hazards and have led to obstruction of evacuation of buildings, rescue operation, economic losses, and extreme cases that damage in non-structural elements cause many preventable injuries and loss of life, as well as economic losses. By non-structural elements constituted approximately 90% of the total cost linked to construction of the building. Structural elements constitute approximately 10%. For this reason, it is important to protect non-structural elements against damage caused by earthquakes in terms of post-earthquake damage, cost and economic losses. Problems of research, despite the loss of life and the property resulting from the behavior of non-structural elements during the earthquake and the damage occurring to these elements, there is currently no national regulation or standard in force regarding non-structural damage. In addition, the number of studies on non-structural elements and this is very low. One of the most reported types of non-structural damage in past earthquake is damage to suspended ceiling system in its architectural components. In this context, general information about suspended ceiling systems and their types is given within the scope of the study. The behavior of suspended ceiling system during an earthquake is discussed as a field studies has been investigated whether the words earthquake behavior, and suspended ceiling are present in the course content analysis of universities in Turkey that provide architectural education and have building project / application project courses in their curriculum. It has been tried to emphasize the importance of getting information about the correct application methods by raising the awareness of architects during their architectural education of suspended ceiling system, which is an architectural component. Definitely, there is definition and types of suspended ceiling system. Today, suspended ceiling system are frequently used in hospital, education buildings, office buildings, shopping centers. The international standard used in Turkey regarding widely applied suspended sailing system addresses the material and dimensional properties of system, but doesn't contain regulation regarding installation instruction, which causes substandard application of suspended sailing system in practice. The absence of installation instruction can potentially affect the dynamic performance of this system. For this reason, it is important to know the suspended sailing system, where the components that make up the system, the correct application. Suspended sailing system can be divided into two system that fix directly on the load bearing construction and system that are suspended by hanging rules. Barriers of suspended sailing system during the earthquake. In general, the moment of the suspended sailing during the earthquake is similar to the oscillation. The vibration duration varies depending on the composition of the suspended sailing system and the motive details. The building and the suspended sailing oscillate differently. The ends of the suspended sailing collide strongly with the walls, and the suspended sailing collapses by being subject to a great force acting on a hull. As it can be understood from past earthquakes, no matter how resistant these structures are against earthquakes, there are always risks. For example, suspended sailing for damage in buildings with minor or moderate damage after the 2023 Kahramanmaras earthquakes in Turkey. Figure 6 AYDIN Governance Office suspended sailing damage after the second earthquake. Then in the second earthquake that occurred in Kahramanmaras, during working hours, according to reports of people, the falling and throwing of sailing elements, especially in public buildings during the earthquake, creates the panic atmosphere, makes the evacuation process difficult. For example, the collapse of suspended sailing of the emergency call center, which was supposed to continue to function after the earthquake, made the employees panic and the damage to equipment disrupted the function of the building. Figure 7, Osmani Emergency Call Center after the second earthquake. There is the relationship between suspended sailing system and earthquake in construction implementation project courses in Turkey. An expected issue in the project is that the designs are made by considering very realistic conditions. In this respect, there are different issues that should be considered as a priority in countries such as Turkey struggling with various disasters. The most important disaster situation for Turkey is earthquakes. It is in the destructive results of seismic moments that the damage encountered in earthquakes are generally caused by the decision taken during the architectural design process. The decision taken during the architectural design process have an impact on the earthquake behavior of suspended sailing system. There are many reasons about the wrong decision taken at the architectural design stage. The most important of this is deficiency in education. One of the biggest reasons for these deficiencies and wrong decision is that the concept of earthquake is rarely included in project courses. Table 1, analysis of the words earthquake and suspended sailing. As seen in the table, 13 of 41 universities, both public and private, have earthquake behavior works in their curricula. However, in some of them, these courses are not compulsory but optional. No results were found in the search for suspended sailing system. Conclusions: it is necessary to protect the integrity of suspended sailing system, as they can cause injuries by being damaged by the effect of the earthquake, closure of escape routes, difficulty in rescue efforts, financial losses, and extreme cases loss of life. As can be seen in the curriculum list, the words are rarely included in application project course content. The lack of national standards and regulation on the seismic behavior of suspended sailing system, the fact that studies from mass structural system are relatively compared to academic studies on the earthquake behavior of structural system increase the importance of concentrating on this issue during architectural education. In addition, in a country like Turkey, where 92% of this geographical land is on active fault lines and struggles with frequent devastating earthquakes, the relationship between architecture and structure and the effect of this relationship on the reliability of structures is of great importance. However, the role of the architect in the seismic behavior of non-structural elements is not taken into consideration much. It can be seen in the curriculum analysis section of earthquakes. This subject cannot find sufficient space in architectural education. But finally, it should not be forgotten that Turkey is an earthquake country, and the precautions that can be taken against these disasters start with architectural designs, decision, and therefore education. Thank you for listening.
Thank you, Sila. It was a very good presentation and clearly describing the role of education in practice, basically, in real life, right? Wow. And the role of architect is actually in Turkey is limited, quite limited when it comes to on-site considerations. So yeah, it was quite informative again. Thank you very much. Let me turn and open my Q&A window if there is any questions. No, there is no question. Maybe we just make the conversation first and maybe I ask questions and then we continue like that. And maybe Yasemin can answer this. Is there any policy? Is there any planning regulation for this kind of temporary structures that Gonca showed us? Is there any established regulation that we can follow, or like a guidance?
Yeah, the planning schools, in fact, are studying these cases and planning of these settlements, but unfortunately not in-depth and holistic regulations, legal and policy regulations are being held. But in theory and in design studios, these are studied. But we saw in in this year's earthquake, unfortunately, they are not implemented or they are not considered even, unfortunately.
Right. Well, thank you very much for your answer. From here, I would like to, I think it's very important to create more resilient urban environments as we are moving towards full-fledged urbanized lifestyle of the digital era, right? And considering the rising impacts of global warming, the changing weather conditions and all these things, I'm wondering again, what you think about the institutionalization process? There can be regulations, there can be planning codes and everything, but what about the institutionalization process of Turkey to implement this on-site, right? Is there something lacking?
Yeah. First of all, yeah, planning in fact regulates and shapes the space, or should shape the space, and within a holistic manner, cities should be designed to create more resilient environments. In fact, planning within its nature targets this. However, when we think about institutional and legal frames in Turkey, there is a holistic frame is lacking, first of all. And for example, after Afat, I forgot its English name, but I guess all of us understand. With 2010 resilience is more discussed and it is more, or it is planned to be more integrated in the planning processes. However, planning implementations, institutions, and legal frameworks are in chaos. So we cannot achieve resilience, I think. In fact, my research also indicated such a point. And we try to have quick results. In the case of 6th February earthquake also, we tried to develop settlements, but the state didn't consider planning. But in fact, we have to plan all the region again once more.
Right.
But unfortunately, they are all theoretical, institutional frameworks are in chaos, unfortunately.
Great. I mean, I got my answer. Yeah, thank you for clarifying. Very helpful. And now another question. Again, I'm checking the Q&A window. There's no question. So dear guests, if you have any questions, any comments, please do share with us while I'm trying to make another question for Idil. It was interesting to see these 32 scenarios based on the calculations, which was partly computational, but partly biased on specific forms, but that allowed us to compare pavilion and slab types of apartments and living environments, basically.
Exactly.
Yeah, I saw in your conclusion, but I would like to ask again that your tests were based on, like, without considering the orientation of the buildings, right?
Yes, exactly. We didn't take orientation as a parameter in this study.
Facing north-south.
Yeah.
Yeah.
Just we used the same orientation for for all of the scenarios.
Right. And in the future, are you planning to do more research on integrating these results into more orientation or topography-based studies?
Actually, you're quite right. We need to improve the study by using different kind of parametric approaches as orientation or maybe topography, or maybe we can generate different kind of building envelopes, so on. There are endless possibilities, of course, but that was just a limited one to just test out the results. So what will be going through when we did such a study for Kahramanmaras. But of course, we would like to just evaluate the results, and we would like to just make another more detailed studies on this kind of evaluation studies, considering that kind of parametric approaches.
Right. Very interesting to see the potential of the work. Actually, that was what I was meaning to get from your answer. And thank you. I think so. Yeah, it can be more computationally complex, and parametrically, it can be this complexity can be parametrically resolved, basically. Right?
Yeah.
Maybe you can use some real case studies, real topographies for that. Right.
Of course, but in that kind of parametric studies, it's really hard to take a real case scenario because that was just based on some assumptions.
True.
Therefore, we need to just make it as simple as it is to just test out each parameter, the impact of each parameter on energy efficiency.
Yeah. That shows us how the potential of your work actually presents itself in different directions, right?
Yeah, that was just a tryout. So we really would like to work on this topic, actually, especially for that kind of regeneration process.
Great to see this kind of research. being implemented. There is also a possibility to develop it in the policy direction, like planning codes and this sort of things, right? Great, thank you very much.
Thank you.
And we saw in the last presentation by Sila that architecture education in Turkey do not consider how to implement suspended ceiling systems. And actually, she is kind of criticizing ourselves that we are not teaching students how to implement these things. So, very understandable and very humble criticize, and I really liked how you put it. In architecture education, there is also like workshops, like internship programs, right? This sort of thing. It's not very easy to identify where the exact problem is for this lack of knowledge, but starting from architecture education and offering that there can be some courses about how to implement suspending ceiling systems becomes very important. And considering like the ethics standards as well, like taking students to the construction site and showing them how to implement those things, you know, like nailing and everything, you know, like they have to touch the tool, right? They have to touch the tool. There is also a missing part in architecture education in Turkey where we are missing like workshops. Is that right? What do you think about the relationship between the
maybe
lack of
training can be
organized
together with professional chambers. Our primary goals was the rise awareness anyway. Thank you.
Yeah, I also wonder one more thing about your presentation. Have you ever talked to, I'm trying to simplify my question. Have you ever talked to some firms that implement this kind of systems in terms of their willingness to be invited to come to architecture schools and show students like for a week or 2-week programs? Like, have you ever talked to them?
Yes.
Right. Good. I think we can get this answer from our experiences. Firms are sometimes willing to come to schools and sometimes not willing. It's sometimes difficult to convince people to be a part of education. I think, but there might be more forums, more sharing platforms between education and practicing people, so that there is a bridge between the theory and practice. Yeah. Thank you, Sila. Thank you very much.
Thank you.
I think this is, I mean, if you have any questions to each other, we can always take. If you would like to discuss anything further, we can always open it. Otherwise, we are ready to finish this session and have a good evening. And thank you. I thank all the presenters and the LivenArch organizers for this valuable platform where we share our knowledge with each other and learn from each other. And it's a very nice tradition of Karadeniz Technical University, and congratulations to all of you. Thank you.
Thank you.
Thank you.